Welcome. This is going to be the last of the coordinate proofs. Write the equation of the circle with the center at -2, 1 that contains the point -5, 5. Is the point 1, -3 on the circle? Show the work that led to your answer. Anytime you're proving or showing something to be true, that's all proof is. Right? It is a coordinate proof. Right? This one is a little different. It's a very specific coordinate proof. It is not like our parallelogram proofs. We have 4 ways to show a parallelogram. Right? This is a very, very specific proof, and it matches one that's on your homework. So because it's so specific, we don't have to write down what we're going to show, right? But we do need to write down the formulas, right? And then answer the question step by step. So the 2 formulas, we need the distance formula, which is the difference in the x coordinates squared plus the difference in the y coordinates squared. Right? And of course we need the distance formula because the radius of a circle is the distance from the center to the edge of a circle. We also need the formula for the equation of a circle, which is x minus h squared plus y minus k squared equals r squared. Right? So that's the equation of a circle. Given center, hk, and radius r. And really, that's all the equation of a circle is just the distance formula. Right? So notice how similar those two are, right? And so if we just squared both sides, we'd get rid of that square root. And that's because all a circle is all the points that are the same distance away from the center. Right? So there's our formulas. Now let's do the work. Right, so we're going to need to use the distance formula to find the length of the radius. So the length of the radius is just a point on the edge minus the center. Make sure you use the point that we know is on the edge of the circle, not the point we're trying to prove. Right, so this would be, right, so edge to center, -5 minus a -2 squared plus 5 minus 1 squared, which would give us, so -5 minus a -2 would be -5 plus 2, which is -3 squared. And then 5 minus 1 is 4. So one of my favorite numbers, I guess. So we have -3 squared plus 4 squared, which you'll know is 9 plus 16, which is the square root of 25, which is 5. 5 just works out really nicely for a circle. All right, so we have the radius. All right, and now we need the equation of the circle. So the equation of the circle we're just going to plug in the center for hk and the radius for r, and that's all we need to do, right? Because there's an infinite number of points on that circle, right? That's why we have to keep the xy. So this would be x minus a -2 squared plus y minus 1 squared. The minus is already in the equation because it's the distance between the points, which is the distance formula. All right, so we've got x minus a -2 squared plus y minus 1 squared equals 5 squared. So now let's simplify. That's x plus 2 squared plus y minus 1 squared equals 25. There's the equation to the circle. All right, and now we're going to do the last part, which is to test the point in the circle. If we get a true statement, that point is on the circle. Right? And all you got to do is plug in 1 for x and -3 for y. So we have 1 plus 2 squared plus -3 minus 1 squared equals 25. 1 plus 2 is 3. -3 minus 1 is -4. 3 squared is 9. -4 squared is 16. And look, we get a true statement. I put it over here. I guess I'll squeeze it in. 25 equals 25. All right, 9 plus 16 is 25, and we had 25 on the other side. So we get a true statement. And let's just justify our work, and then we're done with this particular problem. Since 1, -3 satisfies the equation, in other words, we got a true answer, got a true statement. One -3 is a point on circle. X plus 2 squared plus y minus 1 squared equals 25. And there we go, right? There's our justification, sort of like a little paragraph proof here with one sentence. And we have answered the question. So you can use this one as a model for your homework. Right? Well, thanks for watching. That's my last coordinate proof video. In the next set of videos, we'll look at volume and three-dimensional figures. So thanks for watching. Bye for now.